So our learning intentions for this session is participants will be able to build their understanding of how Minecraft can be used to promote and enhance creativity skills in the classroom. We'll know that we've been successful when teachers are able to share some ideas, hopefully towards the end of this session, on how you could possibly integrate Minecraft education into some future lessons to enhance students' creativity skills. If you're able to locate those ready-made resources within the Minecraft Education app libraries, as well as the Minecraft Education website, and understand some of the ways that world templates could be modified to meet some of your learning intentions you might be setting for your learning sequences. Our presenter today, we've actually had a passing of the baton. We previously advertised this session was being led by Stephen Payne, and Nathan Richards has very kindly stepped in to fill in for Stephen. Nathan is one of the Minecraft Education regional leads for Australia, and he's also the owner of Digital Richards, so he's very well placed to be able to lead this session and very knowledgeable in how Minecraft education can be used in the classroom. And I'd like to hand over to Nathan now, who will be leading this session. Please note we do have an evaluation form set up. You probably would have accessed this for some of the previous sessions. The Bitly code is just there, but I will share this screen at the end of the session as well, just so that we can get some feedback from everybody on all of the sessions. So I'll hand over to Nathan. Thank you, Nathan, very much. And if you have any questions, please pop them in the chat.
All right, wonderful. Thank you very much for having me. I'm just going to bring up my PowerPoint. Let me just double check if this is going to like me PowerPoint live. If not, switch to my desktop. So I'm just going to see if that loads. While it's loading, I introduced myself. So I was just introduced. So I'm Nathan Richards. I part of kind of the Microsoft network as a Minecraft Innovative Educator Expert Fellow. And then I also kind of picked up the role of Minecraft Educational Regional Lead. So do a little bit of work with Minecraft and Microsoft around professional development and the development and the creation of resources. I think I'm going to give up on PowerPoint Live in 2 seconds if it doesn't pop up. Today, I'm going to pop between kind of a PowerPoint and jumping over to Minecraft. Today is very much going to be a combination of, right down to the very basics of how to start with this to, some really cool and interesting and advanced things that are happening globally with the software that may provide you with some inspiration. So there we are there, that's me. But I always like to start these sessions with this very important message around using Minecraft. And it's this idea of we have gamification and we have game-based learning. And just for some of you, you might just be sitting there go, absolutely understand what you mean. But quite commonly when I walk into schools, we see this software being used as a reward and being used in a gamification way. And ironically, actually, last year I was asked to talk at EduTech about gamification from my Minecraft experience. And even I was like, that's not great if EduTech's thinking it's gamification, because it's not. It's actually game-based learning. It's not, we're not rewarding or recognizing students for things like behavior or academic performance by using Minecraft. We're actually using Minecraft to, as a vehicle, as it says there, to leverage learning. So it's all about that teaching method that balances educational materials with the strategies, the rules, and the social aspects around playing games. Gamification doesn't need to be digital either. Old school, or whatever, even if they're new school, star charts are examples of gamifications. They're reward-based systems. So it's this idea of kind of moving away from thinking that just because it's got the word game in it or game-I in it, that Minecraft automatically falls into that category. To kind of why doesn't it fall into that category? This these 6 principles of game-based learning are really key in understanding that. And they come in, they're in the wrong order. So I'm going to challenge you in a second. So you're going to have to use the chat. But these are really good to use when if you're particularly in like a training position, you're introducing this to your school, or you're introducing it to teachers, or you even want to challenge someone who thinks they're quite good at this. But they're the 6 kind of principles that make up this idea of why do we engage in game-based learning? Why is it important? And I guess what's the pedagogy behind it? So I'm going to challenge you on the first one. They get they start off easy. So the very first one there says to fail early, fail often, teach students to take risk in a safe environment, which is the game. The game is the safe environment. So if you think you know which one it is along the top, as I said, it's not systems thinking. So so I was talking about this one here. Which one of these along the top do you think that title suits to? So if you think you know it, write it in the chat for me. But essentially what's so important about this one and why I always put it first is because that game is that safe space. We often kind of have these conversations about kids feel afraid to fail in education, that fear of failure, but you'll notice if you use that game, this tends to disappear, that they quite often are always in this position where they're actually quite happy to fail and then go back and fix it. One of your hardest problems with Minecraft is actually going to get students to stop, because once they get invested, they always want to know, well, how can I make it look better? How can I make it function better? What research can I do to learn how to get it to do X, Y, Z? And yes, we've got the correct answers happening on the screen. So that first one is the failure dynamic. The second one there, if you think you know it, write it in. Provide multiple paths to success. Okay, old school video games kind of had this one way play. Like if you're like me and you remember the old Mario games, like the 2D dimension games, like those, it was kind of, you just had to get to the end. There was a beginning and then there was an end. Donkey Kong or even like Tetris, it's beginning, it's ending. But new games like Minecraft are a bit more sandbox. Okay, they kind of open up multiple opportunities. So anyone want to take any ideas of which one they think that might be? Yes, perfect. Yep, the flexibility dynamic. There we go. Okay, so it's providing that flexibility around learning. There's not just one way to do this, and if you're already involved in Minecraft or you're thinking about it, you will notice that will happen. Students will come up with multiple ways of representing their understanding in the game. So it's highly flexible. The next one there says build something that matters. Okay, students wanted to create things with a purpose. Minecraft let them create something quite often difficult and worthwhile. So which one do we think that might relate to? So with this idea is that what we know is students are already invested in the game. Probably the majority of the students in your class have already played it. And the prime example I give here is that idea of whenever you introduce a new piece of software to students, you quite often have to teach them about the software first before you can even engage in the learning. What you'll notice with most of the students, and I will never say all of them, but most of the students, is that they are already pre-invested in this game. And so they kind of get it. They understand that it matters and that it has a purpose. So for this one, that's all about that construction dynamic, which, yes, Margaret done. Got that right as well. So that fear to not construct something that seems worthwhile to them and it has meaning to them. That next one there, so our fourth one is learn how all pieces can fit or be fitted. Games help players see how their actions fit in the bigger picture, not just as an individual. So this is idea of being part of something bigger that is just yourself. We know in the early years, it kind of, once they hit us in school, they've lost that. But, from that age 3, 4 onwards, that, students only kind of see the world in their eyes and in their lens. That very much that early years concept, that idea, though, of that there are other people involved in this, that there are people that view things differently and in different ways, and the game can bring that about. And that one relates to systems thinking, so how things work. Nice recovery there from Bianca. Second last one is learn new ideas by experiencing them. Students learn vocabulary real time as it pertains to playing with others in the game, or maths as they understand construction. So this is this idea of where we're learning about something we don't even realize it, that you are involved in some sort of activity, and inadvertently you're learning about mathematics, or you're learning new vocabulary as you go. And yes, we are 100% right on that. There's only 2 left to go. So situated meeting. And then we've got the very last one there, which is all about building empathy. And we will talk about social and emotional learning today, but it's about bringing players together, okay, to learn on common goals. It is a fantastic group activity-based technology to use. It can be used individually as well, but it's all about people having to communicate. It's all about students having to work together, about understanding their ideas and building empathy on that process as well. So well done on that. Now, this should work because I'm in PowerPoint Live. At the top, you can see a little goat. If you click on the goat, it will take you to where you can access that resource. So you can either print it, or you can use the digital one that I just did then. So if you ever think to myself, oh, I'd love to do that with my staff or with someone, or do it at a face-to-face PD, feel free to grab that. You'll see those goats appearing throughout. So if you see something and you're like, oh, I'm interested in that, click on the goat. It will take you to the resource for it. If you're not interested in it, don't click on it. So there's a lot of information in here. So if I talk fast, it's only because we've got so much to get through. But what's new? Okay, so if you're invested in this space, if you're brand new, everything's new. But if you're invested in the space, this is kind of what's recently been happening since the beginning of the year. We have had an update in the game. So, and I quite like this update because as you can read there, it actually introduces topics, yes, and items around ecosystems. So in particularly frogs. So there you can actually teach the life cycle of a frog now in Minecraft Education, right from tadpoles all the way up through, and you have to create their environment. You have to create the mangroves in order for them to thrive and succeed. And so students can like physically do that in the game. There's also a few other things there that are added in, so some new biomes as well that may relate to something that you're doing, particularly in the curriculum. There's been some big resources come out from Minecraft, and we're going to talk about this idea of designed resources versus creating resources, but we've seen some new stuff around cyber safety resources. There's been a heap of work done with the BBC around Frozen Planet, and there's some current work around with NASA and the coding. As per usual, every year Hour of Code will come out. You should be able to click on those if one of them is of interest to you, but they will come back up again later on. So let's talk about this idea of designed versus create, and it's a two-pronged approach as to you might do both, you might just do one. It's totally up to you. But there is like I think there's over 200 or 300 pre-designed worlds in the Minecraft Education Library. And when I say pre-designed, I mean the ones that are like thorough. So they've either been designed by the Minecraft Education team themselves, or they're being used a third-party provider that specializes in this stuff. There is content on their website that's put up by kind of what they call mentors, so people who do create their own content. But anything that's kind of got that Minecraft stamp on it is kind of, it's got everything. It should have lesson plans, student activities, very well thought through. And so as an example, I'm going to jump out in a minute to actually show you what this looks like, is you can access it 2 ways. You can access it in-game, and you can also access it from their website, which gives you a little bit more in-depth and quite often more information if that's what you're looking for. So I'm going to jump out, give me 1 second, and actually show you that in-game. So let's stop, let's share. Minecraft. Okay, so that should hopefully come through in a second. So when you land, so you actually land back on this page. So once you log in, you would use your school email in order to do that. The first thing that you will see though is this new in feature. So anything like that I was just talking about before will pop up in here. So that work around the lessons around NASA are in there. The coding lessons are in there. There's the one around privacy as well. But essentially, when we go to play, there's this whole library of resources. So if I click on here, it kind of breaks itself up into 4 main areas. Now, you've got some how to play content, and we'll talk about that a little bit later. So this is more training content. But our very first one are subject kits. And so this is a curated selection. So the in-game worlds are curated, and so not everything is in here. But I can, for instance, choose something like mathematics. Do keep in mind a lot of stuff is based around terminology in the US, but if I want to do fractions, there's 2 fraction worlds here. If I want to do something what they call Common Core, grade 5, there's a whole heap of worlds in here as well. I think the one, that I had before was science, biology. Yep, build with bees. So this is what I was showing you before on PowerPoint. And so really easy, quite simple to access. You can, if there's more information there, you can read it. You can also use the search function at the top right-hand corner if you kind of know some keywords that you're looking for. But that kind of, basically, if you wanted students to use this world, we would just navigate them to that space and get them to click create world, and it just builds it, and off they go. They're ready to go. If you're, I guess, looking for more resources in this space, that's when we refer back to the education library. So if I let's go with the share screen experience. Here we go. So I'm just going to go, I could just even go Minecraft education. There it is there. And we're simply quite nicely quickly on their website. Now, what you can just search at the top here. So I could type in bees if I know that's what I'm looking for. And it's fairly good. You can base it off a variety of different things, but they will come up. So the lessons that I was looking for here on bees have come up as resources. You can also, if you kind of just want to browse in this space, you can look at this tab here, which says Teach with Minecraft, and you can go to Explore Lessons. And those same categories that we saw in the game are also here. Okay, so they're the same groupings. It's just that there's more in here than there is in the game. So in this case, this was science that we looked at, and then I've got all my science worlds that are coming up. And there's my Build with Bees. And what you'll notice about this, it's a little bit different. So this is quite an extensive learning course. There's 11 lessons involved in this Build with Bees content. And what's a little bit different about it is if I open up lesson 1, for example, here, students still access this through the game, but I can see that there are supporting files here. Okay, there's a student worksheet for students to do, and there's also a teacher guide. There are guidelines for teachers, videos that go to the American Beekeeping Federation. It talks about student activities and gives you timing. So basically full lesson plans, expectations as well, and any type of external resources. And so that's that difference between what's kind of really well pre-designed and what's available for you. So the website will give you a lot more detail about what you're looking for. And there is often quite a lot of detail in the in-game, but sometimes you do need to come here to get those lesson plans. And quite often there are things like PowerPoints as well that are used to complement the learning as you go. So let's, I'm going to jump back to my PowerPoint. or actually, let's, we're going to talk about this. Actually, we're going to talk about create now. So, and I want to start off really, really simple. So I'm going to share Minecraft with you again. And I always like giving this example. So always like to tell people, don't underestimate the power of just a simple flat grass world. We quite often get caught up with finding these these beautiful and elaborate worlds that have these amazing builds in them. But if you're especially new to this space, don't underestimate like the real simple core things that you could do just in a blank canvas. And so I've kind of got one I've pre-prepared here. But if I ever needed a new flat world, it's just under new world, new, and then we want to be in creative. So creative just means I have full open access to everything, so I can be as creative as I want. And I would be looking for a flat world. The difference between flat and infinite is probably this picture you're seeing here is an example of infinite. It involves or creates biomes, so mountains and rivers and deserts will be in there. If I just go flat, it'll just be grass. And that's the one we're interested in. So then I would just go play and it would create that. But I've got one here ready to go, which I'm just going to load up. And I'm just going to show you like 3 really kind of simple activities. Let me just fix the weather. So the very first one I want to show you is just around, as an arts example. So this idea of you could just have Minecraft on the screen. Your students don't have it. Okay. If you're confident enough to drive the game, so when I mean drive is, you know, place and destroy and move around. If not, you could ask for a student volunteer and rotate them through. You don't necessarily need to have every student doing this with you. It could just be a tool to help support the learning that's happening in the room. So I'm going to show you a little activity, really simple one, just around understanding primary and secondary colors. So I'm going to press E on my keyboard and I'm going to look for glass, and I've got all these different colors of glass. So I'm going to grab kind of all the important ones that I need. I'll just grab all of these. That'll be enough. And now I'm holding them. And essentially, we could ask that question as to what do we think the primary colors are? Okay, and so a student could respond and say, you know, well, red is one of them. So we put down the red one. What's another one? Blue. Yep, very good. Blue is one, and so on and so forth, and yellow. And then we could say, well, what are the secondary colors? So we know that purple is a secondary color. We know green is a secondary color. And I've forgotten the other one. Orange, sorry. Orange is a secondary color. And so quite visually, we've done that. But then we could take it further and actually explain, well, how do we get to those secondary colors? So ask that question of, okay, well, if I put red down and I put yellow down, what color will that create? And actually, I'll probably even do it over here eventually, but you know, we would work out that that is orange. Then equally, I could say, well, if I put yellow down and I put my other primary color, which was blue, what does that create? And that creates our green. And then I could pose the question again, okay, well, if we put blue down again, but we put it with red, what does that? And then hopefully a student will say, well, that gives us purple. And although probably I wouldn't have done them side by side like that, probably spaced them out a bit. And you can use different blocks. You can use wall blocks as well, so they're not so transparent. But, you know, we've gone through this really nice, simple activity about learning about primary, secondary colors. Equally, I could use these to create challenges around things like reflections or tessellations. So I could, you know, build myself a little diagram like this, and then ask a student to come up and say, can you finish this as a reflection? And so, you know, we would ask that student would come up to your computer and go, well, this would be, whoops, this is what I would do to create a reflection of that. And if you wanted to, even you could even put a line down the middle just by, whoops, sorry, should probably turn those off. but we could grab like something black to just represent. And I'm not really interested by the type of block, I just want the colors. So I'm not getting overly involved in what I'm actually using, I just need something to represent. So there we go. And I won't keep going with, you know, like a tessellation or a rotation, but you could ask the same thing again. What would this look like if we rotated it 90 degrees? And they either, if they're doing it one by one, they physically do it, you know, on their devices, or you may be doing it, or you may ask a volunteer to come up and do it, and they take turns, and you create all these different patterns, or students may create their own patterns and challenge other students to rotate their work or reflect their work. I've seen some phenomenal designs come out of this, things that take up much more space than that. If we look at this from like a mathematics point of view, this is one of my favorite activities I used to do. So if we grab an egg in Minecraft, is that I'd allocate a color to a student, for example, and I'd say, okay, well, you're going to be green, or you're going to be orange. I want you to throw this egg 10 times. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is where I get worried it's not going to work. We didn't get any chickens. So then I'm going to ask the kid who's yellow to come up. Same thing again. I actually got 2 chickens that time. So the yellow student is going to put 2 blocks down. And I asked the student who's green to come up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 as well. You can get 10. It's just the game. It's an algorithm in the game. We just got 1 that time, and that would have been, let's say, the blue. And so what we're creating is over time, and you could do bigger numbers. You could get them to throw 20 eggs or something. We're now creating a bar chart, and we're talking about probability as well. The last one I want to show you is this really nice, unique example, and I actually stole this off another teacher in an early years concept, just around basic counting. So the students chose the animals. So let's go with a pig. And let's go with a sheep. Okay, so it could be something related to a story that you're learning about at the moment. And the teacher, you know, put in 3 pigs there and 2 sheep there. Okay, and then so they just used it and set up a series of these to get kids to learn how to count. How many pigs are there? There's 1, 2, 3. Okay, well, let's put 3 pigs in here. 1, 2, 3. How many sheep are there? There's 1, 2 sheep. And kids were coming up and like touching the screen and going, counting 1, 2. And so then we come over and, you know, 1, 2. Okay, well, let's now count how many pigs and sheep we have together, and we would all count 1, 2, 3, 4, 5. And then we've got our answer, but everyone's engaged and everyone's looking, and every student wants to have a go at putting a pig in the pen and clicking, and that connection between clicking on the mouse and counting was really, really valuable in that early years scenario. So before it rains, I'm going to jump out of there and I'm going to jump back to you and bring up that PowerPoint. So they're kind of like some of my early years examples. And I said, none of those need to or have to involve the process of actually having students in their own world. By all means, you can, but they don't have to. We are going to, let me just close that. That will come up in a second, is talk about this idea now, though, of in creative around individual and multiplayer. If you're new, I always recommend doing individual, 100% every time. Do individual, get them into their own world, or individual may mean just you, and then they use your device and get involved in that way. From behavior management perspective, individual would be much easier initially compared to multiplayer, especially if you're really brand new to multiplayer and there's any technical glitches. The reason why we have kind of so many technical glitches around multiplayer is because it's so well locked down and protected, as in the students in your archdiocese cannot connect with students in another archdiocese, for example. or anywhere else. It's very, very secure, which does cause us some headaches sometimes, but it is too important to not have. So let's jump to that one. So design versus created. So we have those two there, those two ideas between individual, where, as I just showed you, you would just bring up a blank world, or an infinite world, or there are biomes in the library. So if you're doing something specific around deserts, they can go into a desert biome. And then you have multiplayer, which is where students join. And there's a link there if you're kind of interested in it. If you're kind of already into Minecraft, you probably already had a go at this. But I will share that with you. It is a resource that is actually available in the Minecraft game that I helped to design. And if you're new to multiplayer, I really recommend it because it's a really locked down world. So for example, when we were testing this world, I had kids tapping on my shoulder saying, "Oh, so-and-so just threw a trident into the back of my head." And I'd be like, "What?" And so for example, the tridents don't work, basically. They can't use the tridents. You can turn it on if it has context to what they're learning, but all those little things, it locks them into kind of their build area, and it's numbered. So you give students numbers and they go to their space and they build their representation of what they are learning. So in regards to create, I actually wanted to share kind of 3 stories with you, and I take no credit for these stories whatsoever. They're just stories that have been shared with me, which I love sharing on as well. And this first one comes from the US, and it's around about teaching these primary school students about hydroelectricity, and they were in partnership with some middle year students in their design. And so it first started off just with a heap of Lego on the ground. And the kids are just walking all over it and exploring it, and they had to work in groups to build with their middle school partners a dam, because they were learning about electricity, and so they had to build a dam. And so just like we know all kids can get involved in some sort of block building in some way, they built these little hydro dams, these representations. And we know Minecraft is very blocky, so of course we could take this to Minecraft. But what the benefit is in Minecraft, and what we got, or what was taken from this, was this visual representation that looked more like this. And it actually was working. It actually provided power to a village, which is behind it. And when it rained, the dam used to overflow, and the students would use things called redstone, and they could actually, in a virtual space, see how a dam provided power, and they built it themselves, provided power to a local village as well. Another example, a different case here. This one's out of the UK. So this is about a really old building that burnt down in 1899. And was local. This is a local context to the students in that area. They were in walking distance to this old house. It was called Pennycook House. And they got to go to the house, and they kind of safely explored this old house, which was part of their community, it was part of their area. And they engaged with the owners, trying to got some original plans of it as well. And they rebuilt it on a 1-to-1 scale in Minecraft. They rebuilt that house. And essentially what they then did is they went and took that rebuilt design in Minecraft, they put it into a 3D printer, and they 3D printed it. And they actually, you can see it there, they took it back to the house to compare, to basically go through that whole design thinking process and actually come out with something real and tangible. That most schools these days have 3D printers, or it's affordable now to actually give the files to external companies, and they print it and send it to you. But the students were in art, their art classes, they were adding fine details, little trees that you can see there as well to the grounds. They've tried to match the color of the grass as well, but they've gone through this whole design process. The third one I wanted to share with you comes from a gentleman. His name's Stephen Reed. He's definitely worth looking up if you're really keen in just game learning in general, not just Minecraft. But he went to South Africa to a town called Kiji, and Kiji hasn't didn't have a school. It had no school. And so he went there with one laptop with Minecraft on it and one 3D printer. Cost him, a few $100s. And that's all he could have because it was due to a lack of power in the village, a very limited power source. So you can't have 30 laptops running. You probably use up the entire use of electricity in that town if you did that. But he went there with that 3D printer and he worked with the students to design a toy. So still the same idea, still around design thinking. So they designed this toy, they then created it in blocks in Minecraft, and then they used that 3D printer to print that toy. And then they went off and they sold these toys in their town and in nearby towns. And then as a result of that, they used the money from the toys to buy bricks, and they used the bricks to build a school. And so now there's a school in this town in Kiji where there never was before because these students were exposed to some game-based learning. The next area I want to talk to you about is computer science. It's probably my passion area because that's my background. I am a computer science, well, we just call it IT, but this is US, so they call it computer science, but I'm IT trained, that's my area. And there is, I really like how this has evolved in Minecraft. It's really come a long way. Just all used to be about coding, which is important. So we definitely will talk about that. Minecraft released something called Hour of Code every year. I don't, put a thumb up for me if you've used it before. It's always pretty fun. Kids always tend to look forward to it. Excellent. The timing is always terrible. So when Hour of Code comes out, it's always just before we go on Christmas holidays, but it's always there. It's still always there. If you haven't engaged with it, there's no reason to not engage with it next term. And there's 4 years worth of content so far. There is a series of coding lessons. So if you're at that stage with students where you are building algorithms, so which in the new Australian curriculum is kind of like in 6, 7 onwards, where they have to actually be using things like make codes and stuff to bring that in. And then it advances into there's Java and there's also Python as well for the later years. So lots of, you can actually, I don't know if you can see, but like, for example, there's 24 lessons in one pack and there's 10 lessons in another. So it's not just the one, they work their way through a series of lessons as well. You've got some examples like this, which I've been a part of surfacing. So this is definitely more geared at the younger years around where they're a bit more unplugged, but they can engage in building out concepts where they're just learning about, how do we put an algorithm together based on things that happen in Minecraft. So in Minecraft, one of the functions is that you can give someone something. And so we talk about triggers and functions in there. And although that may look completely foreign to you, I can guarantee you that if you talk about a give command to your kids, is that you're going to have a fair portion of them that will get excited about that idea as well. It's gone into this other space as well, which I think is so brilliant. These 3 projects I've been a part of, they're very good teaching resources. So from privacy to being safe online to what are the future careers in this space that don't necessarily mean being a coder. So that one is about data centers, the impacts they have on communities, the jobs that they offer. The other one's about being safe online, and the other one is about online privacy as well. The next one I want to talk about is social and emotional learning. This one's kind of exploded because of another concept that they've brought in, which we'll talk about in a second. But every lesson that's in there, which is based around social and emotional learning, sits around that SEL framework that you can see on the screen. If you're a kind of a Teams user, you might be familiar with Reflect. There's a recent Reflect world that goes in there. So there's a nice little tie-in for you if you're using the Reflect monsters in Teams. The part that I want to talk about, though, is this emergence of esports in Minecraft. And why is that important? And why have I put it just after social and emotional learning? There is a whole heap of worlds available to you, and there's an esports section in the actual game itself around engaging students in the playing of esports as well. But it can be difficult to get up depending on leadership teams and teachers. So I kind of want to talk about why is it important. This here is, might have seen this picture before if you've been involved in any esports training with Minecraft, but this is League of Legends. They had a total prize pool of over $2.2 million amongst 24 players, 24 teams, sorry. It had over 106 million unique viewers. That's so both there face-to-face and online at the same time. If we look at another example, this is called the International, back in the same year, hosted in China. I had a total prize pool of over $34 million amongst 90 players. So it's not bad odds, really, if you think about it. Another huge industry. It's predicted to be the largest sporting competition in the world. But why should we play? Bring that one up. There we go. There's a whole list there of, I'm not going to go through them, of why it's important. And it's all in moderation, like everything in life. It's all in moderation, but it's all about those intrinsic rewards, and it's about those skills that students learn along the way. And you can you can approach esports just from a club's perspective. So just from a sporting perspective, there are so many similarities around what you learn from being in a tennis team or a rugby team or a swimming team as to what you learn from being in an esports team as well. But this is a big diagram, so if you can't read it, screenshot it. Feel free to screenshot it. But this has been mapped out in the recent years, and it was mapped out by Pearson's Education. So Pearson's are a good one to look at if you're interested. They've got a whole curriculum written for this. And these are all the career opportunities that are predicted to exist or already exist in the field of esports. So if we're talking about this, it's really important to not just keep in mind it's esports players. We think about it in any game. We think about AFL or NRL. There are the players, but we all know there are hundreds of people that are involved behind the scenes to make it all work, to bring it to life. From the groundskeepers to the marketing teams, the management teams, to the talent scouts, whatever it may be, the same opportunities are going to exist or already exist in the esports space. This one here was a project that I was part of in regards to, well, how do we like tie it in with technologies curriculum? And it was, so we went into this area which relates to those cards that I showed you before, where students learn how to code with commands, and as a result, they build their own games. So they have to build. They're basically game designers. That's the field. That's the career. There, and they become game designers. They learn all about that as a process, and essentially the esports component was like the reward. It was the part at the end where where students were brought together in an esports style competition, which you can do at a local school level or across multiple schools, where they played each other's games and they were involved in competitive competition. One thing I do like to point out is that we had, like, this gentleman here, it's very hard to see, but this was like one of our student helpers. He was commentating on that. He was brilliant at it, much better than me. He was commentating on the day, so shoutcasting, and they were involved in the technical setup, the running of the day, keeping the scoring of the day. So all of the dynamics, the logistics behind it. We had about 10 students involved in that. They were involved in promoting it and marketing it and everything. They didn't play the games at all. We let them have a go at the end. They versed us and lost, but they were involved with the actual running of it. So from that management perspective, and they absolutely loved it. They want to come back next year and do it again. Okay, cool. The next part I want to talk about is the part I'm really passionate about as well. It's about collecting student work. A lot of people think that you have to collect the world from the students in order to assess it. It's actually the last thing I do. It's my last option. I only collect the world if I want it for myself, because it's really good and I want to show it to someone else. But when we talk about this from a evidence of learning perspective, there are multiple other options that are significantly better, because all you have to do is just capture the understanding. You don't need to capture the physical world itself. If you're a Teams school, it integrates with Teams. So you can embed this as part of a Teams assignment, and you can see the long list there. There's actually probably more now, but there's a whole heap of benefits in putting it in a Teams assignment as well that come along with it around organization. First one though are in-game tools. What's available to you to get students to capture work? There is a camera in the game, and students can take photos of their work and they can put it in a portfolio or they can put it in a book and quill. The difference between the two, as you can see there, is a portfolio, you can only write captions under the photos. So you really got one sentence. A book and quill, you can still do it, there's none there, but you then can write. Do keep in mind there's no spelling or grammar check in here, so you'll get a real up representation of how good their spelling and grammar is, because there's no red squiggly lines that will appear. But both of these can be exported as a PDF document, and then that's what you collect. So the students engage, they put their photos in, they write their explanation of what's happening in that photo or why they built it. You provide all those questions, and then they save it, export it as a PDF, and they hand that into you. So however you're doing that, Teams, AirDrop, OneDrive, however it may be, you might want to print it, could be a book, they could make a physical storybook as well. Your other ones are just kind of nice, simple, basic ones as well. You might be a heavy OneNote user, so you want them to just take photos and put it in a OneNote or put it in a Word document or share it on some sort of shared whiteboard or something. So don't forget just your real basic print screens or print captures if they're on iPads. They keep changing. I don't know which buttons you press anymore, but I'm sure you'll know for your models. So really simple, just screen capture helps. Screen recordings are awesome. Kids love making videos of what they make. We do story time. We do a lot of Christmas time every year. We get kids to build like nativity scenes. They build the scenes out one by one, and then they film, and because they're the characters, so they're moving around. Nice little group project. So you got your multiple different screen recording options there as well, depending on whether you're iPad or MacBook or on a Windows device. If we are talking about them though wanting to show stuff in worlds, they have these chalkboards that are available. So they come in 3 sizes: slates, posters, and boards. And they can write on them. Just the bigger they get, the more writing that you get. You do also have signs. I don't recommend signs because they're hard to read, in my opinion. Chalkboards are better because they always have a black background and white text. They're simple. It's easier for you. I'm all about making it easier for the teacher. And so students can put directions or information or whatever it may be in that space. To kind of step up a little bit, you can also use these. These are called non-player characters. And that's where the students, the video or the link there, will explain how to do this completely, but the students change their settings a little bit, and then they can edit the non-player character. It doesn't walk around or anything. It stays exactly where it is. It spins, but it doesn't move. It doesn't follow you, but you basically go up and talk to it and interact with it, and it tells you information. It may give you clues, or may tell you something about, the First Fleet or whatever it may be. And it can also send you off to other places. So if you do any work around commands, you can put commands in there, or you can put links to like websites and stuff. So let's though try to contextualize it. So I've used the SAMR model to try and, that's a lot of information. So what are 4 solid examples of moving from a pedagogical model around substitution, augmentation, modify, and redefine? So I'm going to give you, these aren't the only ones. I've got more, which I'll share with you as well, but I've just kind of chosen one of each. So this is a nice example for substitution. This is where students just use the inventory, just like I was before. I was using those glass blocks. Okay, that's a wool block. And they just create a 2D item or concept, such as pixel art or poster. We've been doing pixel arts and posters for years in schools, but you can do them in Minecraft as well. And I take no credit for this activity, but this is a really nice one, which can be rebuilt out as well, or students can build their own guides as to how to build that pixel art as well. So they physically build it in the world. There are some monthly challenges in there as well. And a common one that I see people use all the time is there's a giant book, and then you get the students to build a cover for the book, like in the same way they would here. It wouldn't be standing upright, it'd be facing down, but they build a cover for the book. So that may complement something you're doing in English, for example, where they all then create their own book cover for the story that they've been reading. We then got Augment. Let me just see if this will play. There we go. So this is where students, they'll use that inventory and they'll actually create a model. Okay, so it becomes a little bit more three-dimensional. And it may, this is an example of a diorama. This was, I was brought into a school, you know, classic dioramas across the back about natural disasters. A whole back wall full of them, and there was this really terrible one, and I got asked, like, just, you know, do whatever, and I saw these dioramas, so I said to the kids, we're going to rebuild your dioramas but in Minecraft, because we're going to bring them to life. And this this student had built this meteor hitting, and it was, to be honest with you, I wish I took a photo of it, but it was just like he glued some grass to some cardboard and then put like a wire and just put some put like some alfoil and some string off it, and that was his meteorite hitting the Earth. And it's just because he wasn't engaged in the project in that way. But this is what he built for me in Minecraft instead. And when I sat and I spoke with him about it, and, you know, asking about, well, you know, why are these blue glowing stones? And he's like, oh, that's because the meteorite isn't from our planet, it's come from another planet, so it may contain minerals or resources that we don't have. And I'm just like sitting there going, and his teacher's going, oh my god, I didn't know he knew all this. And so we had to go back and change his assessment, or change his grade based, because he did have all this information, he just didn't have the right tools to explain it. If we look at modify, so this is where students start using like levers and commands, so the technology curriculum comes in a bit more here. But you can see in this example where people are posed with a question, and then we have to choose the right one. Now, if you pull the right lever, it will open the door. So chosen the wrong one, that's the right answer. And that kind of brings in some mechanics around Minecraft, so it does require some additional learning in that space, but students kind of bring that contextualization into the game and make it super interactive, so that you can understand the idea of developing a correct answer versus developing an incorrect answer. And then this last one here is a little bit around that 3D printing concept. And this is where we had students building, you know, that understanding of electricity. And so this was their diorama of a, it does spin. I think it was spinning very, very slowly, but it's a 3D artwork, which you can put into PowerPoint as well. And it loads like that as a 3D diagram, and you can get them to turn and stuff. But they built a 3D representation, put it into PowerPoint. I don't have all the slides, but they actually broke every section up and then presented each section as a PowerPoint. And so they're using technology that's only available in Minecraft in order to do that process. So there are heaps of ideas here. I know you can't read that, but if you click the goat again, it'll take you to a page where you can see lots of different ideas. It is really easy to get into the transformation stage in Minecraft. It's actually, I think it's more difficult to do the substitution work than it is to do the redefine and modify, personally. So so call to action to finish up. A couple of more resources that I'm going to leave you with is, if you do need supporting resources, if you need to go to leadership to convince them to use this or to use it in a particular way, there is so much on there. There's a recent article around the student-centered approach to Minecraft that came out of Dublin, which is very very good. If you're looking for more training, there's actually one coming up really that with July 25th, 27th, and 31st. That's actually run by the Minecraft education team as well. So it's all online. Just make sure if you register, you pick the time zone for Australia. Otherwise you'll be up at 2 a.m. Doing this. And this is fundamentals. So no Minecraft experience needed at all to be involved in this. If you can't make those times, all the courses are on MS Learn, so Microsoft Learn, so you can log in there. There are heaps of courses and pathways you can take around learning more. I know, for instance, there's a recent course that's just gone in called 401 Redstone. So if you're on the call and you know what Redstone is, you can go in there and learn all the different facets of Redstone and how you could use it in the classroom. This is new. So if you don't mind being on Facebook in an education perspective, they've just kind of recently launched this. I'm impressed there's already over 6,000 members in there, but it's a little bit of a education community of people asking, they're meant to be asking questions around like curriculum and ideas and implementation, because there is also a separate support website as well. So really, this is a really good website for any IT technicians that you have, or even yourself. You can use this, and this is where you go in and log things around IT issues or supports, or things aren't working and you don't believe it's a school-based issue, believe it's a software one. Very responsive IT team there at Minecraft. But that's all I have for you today. I hope you've managed to get some resources out of that. Happy to stay on if anyone has any questions, but thank you very much for having me.
Thank you very much, Nathan. That was fantastic. I know even as an experienced Minecraft education user, I've picked up a few great ideas and a few hints that I'll be able to take away. If anyone would like to share some of their ideas or key takeaways, something that they might take back to use in their classroom, or a way that they might be able to link Minecraft education with learning that you're planning for next term, we'd love for you to share in the chat. I'd like to say thank you again to Nathan for presenting the session for us today. And if you have any questions, please pop them in the chat. We've got one from Lee. He or she, I don't know, has asked, is there a teacher dashboard with all my students on a page once they've joined my world or lesson? So that would be to do with that sort of when you're managing that world as a teacher and you've opened that up, can they see all the students that are in there to be able to keep track of their progress?
Yeah, so if you're hosting a world, when you hit escape on your keyboard, you'll get a list that will come up of the students, so you can see who's in there. It's quite helpful to look at as well, because it gives you a total number at the top. So if you know you've got 24 students in your class, the number you're looking for is 25, because it has to include you as well. So, but you can scroll down through that list to see who's in, and by default, it normally just says their name and then the initial of their surname.
Wonderful. Is there anyone else that has any questions? Please feel free to pop them in the chat. I'm hoping that everyone is busily completing the evaluation. Super. Okay, everyone, this session has been recorded. So if you do wish to come back and revisit some of the content that Nathan has presented today, you'll be able to access that through the recording. Sharon has asked, if a student goes rogue in a shared world, can you track who it is? So if they're griefing, Nathan?
Not really. Like, the one big thing about Minecraft is there's no Control Z, which people hate. I definitely, so I think I shared a world earlier. It's called class build plates. Those type of worlds have things like griefing turned off. So like, for instance, they can't go get TNT and put it in someone's house and blow it up. Yeah. So if you're new to this and you're not like 100% confident, those worlds are really useful to use because students have limited control or access over that. But you can change a student if you've find that student, or if you know who it is, you can change them just to like a visitor, so they can stay in the world, but they can't do anything. They can only look. But to be honest with you, if you to actually backtrack what they've done isn't possible.
Yeah. I think it's one of those types of applications that it's a really good opportunity to promote digital citizenship and those norms about, and, you know, respectful behavior and what that looks like in a virtual world.
Yeah, 100%.
Fabulous. I've shared a lot of the links that were in Nathan's presentation in the chat, everybody. The chat you won't be able to add to afterwards. It's only available while we're in the meeting. So if you do want to go back through and grab some of those links, but we will try and get some of that information up with the information when we upload the recording on the CLO website in the coming weeks after this summit. Thank you again, Nathan. We really appreciate your time today. It was a wonderful, very informative presentation. It's given us lots of ideas. I just really want to also quickly show, we actually ran a Minecraft challenge at diocesan level, and we had students recreating different world landmarks and sites. This was something that students were completing voluntarily as part of, and they created a whole bunch of different sites. We had lots. We even had a mini Woolworths that was created by one group. These are just some of the ones that were created by some of our students from primary school and secondary as well. And we've got some really great examples. And if anyone would like to see this in further detail, please feel free to shoot me an email, and I'm happy to send off the link so that you can actually have a look at it, because that's a Google site. And those worlds are also downloadable as well. So if you're looking to share some student examples, if you're looking at running either a class challenge, and there's lots of challenges available in the library as well, isn't there, Nathan?
Yes, yeah, just look for, or it's either search or look for monthly challenges. There's heaps in there.
Perfect. Okay, we'll finish up there. I'm going to stop recording.